I'm Shauna, the CEO of Inflatech Industries. I worked on the cushion cover, algorithm research, editing, interviews, and controller research.
I'm Carissa, the COO. I worked on bladder fabrication, component layout design, and the firmware algorithm.
Hi, I'm Calvin, the CTO. I worked on firmware review and implementation, as well as component research.
I'm Vlad, and I was responsible for the underlying hardware, component integration, firmware implementation, and controller assembly for this project.
Hi, I'm Frank, the CCO. I worked on the user controller assembly, documentation, and managed communications.
I'm Alexa, the CFO, and I worked on documentation, pressure algorithm research, and funding applications.
This informational video will teach you everything you need to know about operating your care chair. First of all, we'll provide some background information about pressure sores and how our device can help prevent them. Secondly, we'll go into care chair setup, use, and finally maintenance.
According to the World Health Organization and the Wheelchair Foundation, 1 to 2% of the world population requires the use of a wheelchair. Taking into account people who actually have access to wheelchairs, this number translates to 21 million wheelchair users worldwide. People who require the use of a wheelchair are at heightened risk for pressure sores due to the excess of pressure, shearing force, friction, and moisture. Pressure sores can form within a few hours, and in extreme cases, they can cause extensive damage to the underlying tissue, bone, and muscle. After discussing with nurses, we found that there's a great industry need for something that will work to prevent pressure sore formation in wheelchair users.
At Inflatech Industries, we're designing the care chair as a supplementary device to be used in conjunction with the current standard of care for pressure sore prevention. The care chair is a smart wheelchair cushion which monitors patient pressure and uses pneumatics to readjust their position to relieve high pressure areas. Other important features of the care chair are the pressure map, which provides feedback and alerts, the user controller that allows for different modes of operation, and the spill-proof outer casing. This makes the care chair ideal to use by both patients and caregivers in clinical and at-home settings. This system is designed for use in standard wheelchair sizes of 18 by 16 inches and can hold patients up to 220 pounds.
The care chair setup is easy with a one-time initial installation. Attach the electronics to the bottom of your wheelchair using the attached Velcro straps. The box should not impede your ability to control your wheelchair, so test out the positioning by moving around a short distance. Next, place the cushioning on the wheelchair with the pneumatic tubes coming out of the front. Press down gently to ensure a secure Velcro connection. Third, insert 3 AA batteries into the controller and connect the Raspberry Pi to a suitable power source, which can be a wall outlet, suitable power bank, or electric wheelchair outlet. Finally, attach the controller to the preferred armrest and press the on button to power the care chair up.
The user controller has key features including the pressure map, alert system, and mode toggling. The top of the controller has a system power button and the mode toggle switch. The LED pressure map indicates the current pressure distribution to the user. A red LED means the area has been under the 0.6 psi danger threshold for 15 minutes. Yellow means that it has reached 0.6 psi but for less than 15 minutes. And green means that the tissue is in a safe pressure zone. At any point of time, the user can press the current position button to display the pressure map. In automatic mode, the system will issue an alert of a flashing red light and a vibration every 15 minutes to warn the user that they are about to be readjusted. Controller LEDs will flash the projected movement. Then the system automatically moves them. In manual mode, the user is able to customize their movement to a degree by choosing a direction with the joystick controller. If the direction chosen will not increase pressure, the LEDs will flash green in response and then flash the projected movement. If the direction will only partially relieve pressure, the LEDs will flash yellow and then the current pressure distribution will pop up as a reminder. If the user attempts to move in a way that will increase pressure in already dangerous areas, the LEDs will flash red signaling an error. The system will not allow the user to move. If the user does not choose an option in manual mode within 15 minutes of an alert, the care chair will move to the recommended position.
To demonstrate automatic mode, the user begins by switching the toggle switch to automatic mode and turning on the power to the system. When the user presses the current position button, we see the lights on the pressure map flash with red in the back right LEDs to indicate the dangerous pressure in that area, and green in the rest of the LEDs to indicate the low pressure. After a period of time, the red alert button begins to flash and the controller vibrates to tell the user that they will be repositioned automatically. The pressure map then flashes the projected new pressure distribution after they have been moved, and the process of repositioning the user begins. We see the user is tilted to the left by the system, and the previous high pressure areas were alleviated.
To demonstrate manual mode, the user switches the toggle switch to manual and turns on the power. They press the current position button to check their pressure distribution and begin attempting to reposition themselves with the joystick to relieve the areas with high pressure. Their first attempt results in the pressure map flashing red as their chosen direction would increase the pressure on dangerous areas. This is then followed by the map flashing the current position once again to remind the user of their current high pressure areas. Pressing the move button at this point would not result in user repositioning, as the built-in safety feature prevents the user from putting themselves at risk of pressure sores. A second attempt with the joystick results in the pressure map flashing yellow because their chosen direction will only partially alleviate pressure. Again, the user is reminded of their current position with the flashing pressure map. Using the move button now would result in the user being partially repositioned. Finally, the pressure map flashes green once the user chooses a position which will totally alleviate pressure. We see the user decide that this is the optimal direction for relieving their pressure and confirm this direction with the move button. The system now begins to reposition them into their chosen direction.
To ensure patient safety, the Care Chair was designed to be easy to clean and maintain. The batteries for the controller can easily be replaced by removing the backing from the components and placing new batteries inside. To clean the cushion, open the flap at the front of the cover and slide the pneumatics and pressure map unit out from the cover. Next, open the back of the cover and remove the memory foam insert from the pocket inside. The cushion cover can be machine washed in cold water and hung to dry. The memory foam insert, tubing, and pneumatic bladders can be wiped down with cleaner. Once everything has dried, the components can be returned to the cushion cover and placed back on the wheelchair seat.
The Care Chair is aimed to provide a better option in preventing and help alleviate pressure sores. It is also meant to help healthcare workers provide a better standard of care by making more informed decisions and improve pressure relief techniques, and to also provide them with more time to attend to patients' other needs. We would like to thank Shervin and Andrew for being able to adapt and provide help during this pandemic. We would also like to thank all the TAs who were able and helped us during this 8-month journey. Michael and Joshua from NSI 440, Chakave, Mohammed, and Reboir from NSI 405. Thank you.